Okay, so chapter 13 will be the last chapter of the year. I bring you good news about this chapter. Every day gets easier than the day before it. Okay, so we're going to go through this week 13.1, 13.2, 13.3, 13.4. Every day will get easier than the day before it, meaning today is the hardest day. And I don't know that I'd even say this is like truly hard compared to other things that we've done. But if you can manage today, every day beyond this will get easier. So the whole chapter 13 is about a thing called sequences. So sequences is going to take you on like a 7th grade and elementary school flashback. You've been doing sequences for a long time, just not quite like this. A sequence is simply an ordered list that follows a rule. There's some kind of pattern to how these numbers are coming, and you either like swat it quickly or you puzzle over it, sometimes for a while, but usually sooner or later it comes to you what the pattern's about. So in 7th grade world, I'd give you this sequence and I'd ask you who's next, and you'd say 11, 13, so on and so forth. Okay, that's not really what we're doing largely in this chapter. Sometimes a small part of your job is figure out who's next. But the big thing of your job in this chapter is to figure out a thing called the general term. So here's some just punctuation to get us on our way. Since this is the first term, I'm going to call this A1. I'm going to use a 1 subscript for the first term. So what do you think I would call this?
A2.
A2, because it's the second term. A3. A4. A5. A6. Those would be the names of those things. The general term is always going to be an AN and have a variable in it. And what we're trying to do with this general term is describe any or all of the terms, so that if we would plug in 1 to this formula that we're going to have to come up with, if you plug in 1, you'll get out the first term. And if you plug in 2, you'll get out the second term. Plug in 3, you get out the third term. So here would be a wrong example of this. You might look just at this matchup and think, okay, what I should do is multiply by 3. Because here, if we took this times 3, it makes that. But why is that a lie?
If you do the second one, it can be 6.
Because the second one should get us, and instead it would get us 6. So multiplying by 3 is not it, because this should get us 9 and 12, and that isn't it. So then you might try something else and think, okay, what if I added 2? If I added 2 here, that works for this one. Does that work for all of them? No. But there is some kind of math thing that you can do to all of these numbers, do the same math stuff every time, and it would get you out those answers. You might not be ready to do that yet, maybe we'll come back. But can anybody figure out a way to do that? You do some kind of math with 1, 2, 3, 4, 5, 6, and you will get out 3, 5, 7, 9, 11, and 13.
I know it's like it's plus 2, but I forget how you set that out.
No, it won't be a plus 2. I'll come back there. Okay, the easier way to do this is if they give you the general term. Okay, so half the homework is them giving you the general term. Half the homework is you coming up with the general term. So let's do an easier one where I give you the general term. So if I say the general term is -1 to a power and a number getting squared. If I want to figure out the first 4 terms, I would plug in 1, then I'll plug in 2, 3, 4, and for the 10th term, I'd plug in 10. Okay, let's do the 10 one first. If I plug 10 into this, 10 squared, something to do with 100, what's going to happen when -1 goes to an even power? It would be positive. Question about how I pulled the 100 by plugging in 10.
Is that first sequence times 2 plus 1?
Yes. We're going to just plug 10 in. 10 squared is 100. And if I do -1 times -1 times -1 an even amount of times, that's going to be positive. You get that?
Where did we get the little 10?
I gave it to you. So I'm saying to you, here's the formula that can create any term you want. I want you to create the 10th term, and I want you to create also the first 4 terms. So let's double back to this one. If we plug in 1 to get squared, that's 1. When 2 gets squared, 4. When 3 gets squared, 9. When 4 gets squared, 16. The question is just what's happening to this -1 that powers things. When -1 goes to the first,
It's -1.
it would be a negative sign. When we go to the second power, 2 being an even number,
Positive.
positive. Put in the 3. Odd number?
Negative.
Negative. Put in 4.
Positive.
Positive. All this is going to make happen, if you see -1 in parentheses to a power, what's it going to just make that happen?
Flip. Change size.
It's going to take turns with the signs, negative, positive, negative, positive. They're just going to bounce back and forth. Question about that? Okay, so let's slide back over here, and we did come up with an answer, so let me give you some tips as to how to maybe do this. So there's some sort of math that 1, you do this math, it always gives you 3. 2 would always give you 5, 3 gives you 7, etc., etc., etc. Does anybody have a thought on what 10, other than Nicole who gave us the pattern away already? If we were doing the 10th term, can you figure out what it would be? It would be 21. Because there's some sort of relationship that the 10, you math it, it would always give you 21. If I wanted the 30th term,
61?
it would be 61.
I swear to God.
If I wanted the 100th term,
31 plus 30. 201?
it would be 201. Sometimes people are very quick on that. They're just like, oh, I see it. And sometimes people want to bang their heads on a table for a little bit. Okay, it can get frustrating sometimes. This just involves you plugging in numbers. This involves you being able, having to be a little bit creative. So here's what Nicole suggested is, it's 2 times stuff plus 1. And that's true. If we take 2 times these, and then add 1 every time, it makes that. So how do you think of that? Well, plan A is be good at math, and the numbers just like appear from the heavens to your brain, and you're like, thank you brain, thank you heavens, they just appeared. That doesn't work for a lot of people necessarily. So here's a different way we could go to approach this, is recognize every step, what's it doing? It's going up 2. So add 2, add 2, add 2, add 2, add 2. What got invented in math in your early elementary school life, instead of adding 2, adding 2, adding 2, adding 2, adding 2, adding 2, somebody introduced you to multiplying by 2. So if you see the pattern is going to add 2, add 2, add 2, add 2, add 2, add 2, it definitely has to do then with 2 times that n. And then if you think about 2 times 1 and 2 times 2 and 2 times 3 and 2 times 4 and where we're always trying to get, just the multiplication by 2 alone always leaves you short by 1. So you end up having to add 1. Tomorrow, every sequence is going to be an adding sequence. They're called arithmetic sequences. Tomorrow, you won't have to be creative. There'll be a formula that you could just follow if you memorize it. Some people like to be creative. Some people would rather just memorize a formula and use it. Tomorrow, they're all arithmetic. There'll be a formula you can just memorize and use if this creativity is not your cup of tea. If we go to do this one, is this one also arithmetic? Yes, because every step, what's it adding? It's adding 4. So it's going to add 4, add 4, add 4, add 4. So for sure, the general term has something to do with 4 times that n.
Is it lunchtime?
We'll get there in just a second, but yes. And then maybe number these off. 1, 2, 3, 4. We know it has to do with multiply by 4. If it's going to add 4, add 4, add 4, that's just my personal guarantee. 4 times stuff. And then think. 4 times 1, 4 times 2, 4 times 3, 4 times 4. It's getting us into the neighborhood, but we're always 1 too high. So subtract 1. Question about that.
Where are we getting the -1 from the minus
If you
1?
think about, are you okay with it's got to be 4 times somebody?
Yeah.
So then think, number them off. 1, 2, 3, 4. 4 times 1, 4 times 2, 4 times 3, 4 times 4. Think about the results those would make. The numbers that would come into our brain when we're thinking about 4 times these don't perfectly make those. We're always too high by one.
Okay.
So we subtract one that like fixes it.
Yeah, that makes sense.
Anybody else want me to make up another one that's arithmetic like that? This one's not arithmetic. We're 2 days away from this. This is called geometric. This does not add the same number every time. What does this one do? It multiplies the same number every time. So if it's going to go times 2, times 2, times 2, then the general formula has to do with another math thing that you learned. Somebody at some point in your math careers just told you to go times 2, times 2, times 2, times 2, times 2, times 2. Don't do that. Just do powers. This has to do with 2 to powers. And then we'll just try to check it out. Number these off. 1, 2, 3, 4. Is this 2 to the 1?
Yeah.
Yeah. 2 to the 2?
Yeah.
2 to the 3?
Yeah.
2 to the 4?
Yeah.
So get out. Questions about that? Let me change it. If I go 20, 40, 80, 160,
What do you do?
would that still be 2 to a power?
Okay.
Yes, because it's still multiply 2, multiply 2, multiply 2. Those are called geometric sequences. If it's going to multiply 2 every time, do 2 to a power. But then when you think about 2 to the first, and 2 to the second, and 2 to the third, and 2 to the fourth, which makes these, they don't turn into those unless you also multiply by 10. And now we're good on that.
Sure here.
If you're good at being creative, you can be creative all chapter. If you're not good at being creative, wait till tomorrow where the arithmetic will give you a formula you can memorize, the geometric will give you a formula you can memorize the formulas, and you don't have to be as creative. But for a day, you've got to be creative. That's what makes this the harder lesson. Sometimes right away, you're like, oh, I see it. And sometimes you look at the pattern and you're like, oh my goodness, no. Then you skip it, move to the next one. Okay. Something there. Okay, this one I did fractions, and I sort of like disguised them. So I'm going to undisguise these before we try to do this. Does anybody know what I mean? How do fractions sometimes get disguised in sequences?
They're not like to the, but you can put them all to a GC
Maybe.
or common denominator.
Yeah, maybe. What's something you commonly do to fractions, or I expect you to? And
You
it's,
simplify, like you reverse simplify
you
them.
simplify them, yeah. 1/2 would be, it'll be easier to recognize the pattern if I traded in 1/2 for a different friend.
0.5.
Not going to go decimal, I'm going to stay fractions. What's a half alternatively? 2/4. A half is 2/4. If I change that to 2/4, it's going to make a little bit more of a clear pattern.
Oh.
What would you expect is going to be under my hand? 4/6. Because the tops went 1, 2, 3, the bottom went 3, 4, 5. Is that 4/6? Yeah. So sometimes the fractions, because of reducing, get a little bit disguised. Does this one look good?
Yeah.
Yeah. What would this one rather be?
6/8.
6/8. But if you're looking at a big list of fractions, sometimes you're better to like undisguise them. And then just number them off. 1, 2, 3, 4, 5, 6, 7. The general formula is certainly a fraction. We're trying to look for something that, we're calling these ends. 1, 2, 3, 4, 5, 6, 7, those are our ends. We're trying to create a fraction that would make the list. Anybody do that? So try it with numbers. If I gave you 11, what fraction would you make?
11.
Top would be 11, bottom would be
13.
13. If I gave you 47, the top would be
47.
47, bottom would be 49.
So, and
I'm giving you n.
n would be on top.
So the top would be n,
Would the bottom also be
n plus 2.
bottom would be n plus 2. My best tips are, if it's going to add every time, look to multiply. If it's gonna multiply every time, look to use powers. And if they do something else that's weird, just do your best, okay? Number them, 1, 2, 3, 4, 5, 6, 7 in order. And if you're having trouble thinking about the ends, don't think about ends. Think about any, what did I do?
Just a random number.
Just any random number. See if you could do it with a random number. Because here we couldn't do it with the ends, we were stuck. But whenever I threw you an 11 or a 47, it was like, oh, okay, I can do that now. And after you do a couple random numbers, maybe that can fall into place. Or maybe it doesn't. Maybe you just have to skip it and move on. And wait for another day to come. But question there? The second thing is called series. A series is just a sum of terms. So we'll hit a dividing line in the homework. Anybody know what Greek letter this is? It's part of your modern teenage slang vocabulary. It is a sigma.
I knew it.
The Greek letter sigma has to do with just adding things. I don't know what it means in your teenage lingo. I hear people talking about alphas and betas and sigmas and all this stuff. I don't know. That's all just temporary foolishness that'll be gone in a year anyway. But this is the letter sigma. Sigma just means you need to add up a bunch of stuff. Okay. The way I would read this, I'd read this as the sum. I'll write the words for it. The sum, as k goes from 1 to 5 of 2k plus 1. What this is expecting you to do is take the 1 and just plug it in. And after you plug in 1, plug in 2, 3, 4, 5, and after you plug in 5, stop. Just get out. Okay, so this is expecting you to plug in 1, 2, 3, 4, 5 into that formula and just write it as a big adding problem. So plug in 1, 3, 2, 2 gets you 5, 3 gets you 7, 9, 11, and just add. Likelihood is they just want the adding problem. If you look in the back of the book and then they added them up, well, guess what? Just add them up. Be okay. Question about that? So what's this one expecting us to do? Plug in 1, 2, and 3. Plug in the lowest number and keep going up until you hit the higher number. So let's do the powers first. 2 to the 1, 2, 2 to the 2.
What's your sigma rating?
4, 2 to the 3, 8. And then what did we decide this was going to make us do a couple problems ago? It's just going to make the signs take turns. Just make sure you get the right starter sign. Since we were plugging in an odd, negative to an odd is negative, so then this would go positive.
Negative.
Question about that? Just take 1, 2, and 3, because that's the stack of numbers. So they just get plugged in one at a time. Let me make a small change. If I go with an add 1. Now if I plug in 1, 1 adds 1, now that's 2, which is even, which makes this positive, which would make the next one positive. If you get the first sign right, they're just going to take that. That's going to be easy. If they give you the formula, you just have to plug the numbers in. That's going to be pretty easy. What's going to be harder, is if you have to make the formula happen. So if I go 1, 4, 9, 16, 25, we need to puzzle at that until either a light bulb goes on and a voice comes from the heavens that tells you what those numbers are doing. Or you stare at it until you get sick of it and you skip it and move to the next one because it just isn't going to happen for you right now. And those are both valid strategies. This is not arithmetic. When I say arithmetic, what do I mean? Adding the same number over and over again. This is adding 3, adding 5, adding 7, so that's not arithmetic. It's also not geometric. Geometric means it's multiplying the same number every time. And that's not what it's doing. It multiplied by 4, and then it didn't multiply by any kind of whole number. If it's arithmetic or geometric, it's going to be an easier time. If it's neither of those, you've just got to be creative.
I mean, I can see that it's adding like consecutive odd numbers.
It is adding consecutive odd numbers, but we'll have a tough time writing that formula.
Is it just one square?
It's squares. This is 1 squared,
Nice.
2 squared, 3 squared, 4 squared, 5 squared. Instead of n's, for whatever reason in the series group, they switch to the letter k. I don't know why, it just is, and I just go with the flow. But our k's are getting squared, and the k's would run from
1 to 5.
1 to 5. Question about that? If I go like this, is it still squares?
Yes.
Yes.
It would just be the k equals 2.
But we're running now from
2 to 5.
2 to 5. If I wipe that out,
2 to 4.
now we're running from 2 to 4. Question about that? I'm not suggesting you do this, but I could do k's going from 1 to 3. 2, 3, 4, there's 3 numbers there. 1, 2, 3, there's 3 numbers there. If I went from 1 to 3, and I'm going to go 2 squared, 3 squared, 4 squared, I'd have to add 1 before I squared. This is just as true as this,
Yeah, but it's a stupid extra step.
but it's an extra step. But if different people get different answers, that might be. Okay. Give me like a ridiculous number.
17.
17. So since there's 3 numbers, we'd be using 17, 18, 19. Those are still squares, but to reduce 17, 18, 19 to the 2, 3, 4 that we're really squaring,
Minus 13.
k would subtract.
Okay, I can figure it out.
60.
2, 3, and 4 are getting squared. So we need to get these numbers down to 2, 3, 4.
Minus
15.
Minus 15.
That'd be great if I did.
All 3 of these are equally valid answers. You'd be kind of weird if you did that one. You'd be a little bit weird if you did this one. I think that's the easiest way to go, but just come up with something that works and you're good. Something there. This one is definitely
Negative. Like,
a word from the lesson. A word.
Arometric.
Arithmetic, because every time I'm adding 1. So I'm multiplying by 1. So those have to do with k's, which my k's run from 2 to 6, because we can clearly see 2, 3, 4, 5, 6. But what's the one thing we have to take into account that this doesn't yet? The fact that they're switching signs. So -1 to powers. Maybe k, maybe not. If we try the first one to see if we're right, 2 plugged in, negative to an even power is positive. We want the first one to be positive, so that's a win. Something there. This, I'd again run k's
2 to 6.
2 to 6. Definitely the formula has
Okay.
k. Definitely to take turns on the signs, we have -1. But if you try to do k again, the first one, when you plug in a 2 and it's even power, that would be
Negative. But it should be positive.
positive, but we want it negative. So how did I offset that a couple problems
Just do
ago?
+1.
I could either go +1 or -1, it doesn't matter. But adding 1 to any odd makes it even, and subtracting 1 does the same thing. Question there? This one's definitely arithmetic. So what's it adding every time? 4. So definitely 4 times. Okay. I'll do this 2 ways. If I'm going to go 4 times stuff, what's a number that gets me into the neighborhood? 0 could. I'll do this three-way step. Who else gets us in the neighborhood of 6? 4 times 1 gets us in the neighborhood. 4 times 2 gets us in the neighborhood. So if I want to go 0, I'd go 0, 1, 2, 3, 4. So if I go 4 times 0 and 4 times stuff, I'm a little bit off always. By how much? 6. I need to add 6. I would probably have not done that. 4 times 1 gets me closer. If I'm calling this 1, this one's 2, 3, 4, 5. So if I go 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, and I run from 1 to 5, I'm closer.
You just need to add 2.
I just need to add 2. If I went 4 times 2, this one would be number 3, 6. So 2 to 6.
And yes.
4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6. I'm super close. Minus 2 this time. What's the best answer of those 3? They're all the same. Doesn't matter. Find one that works for you. Move on. Something there?
Is that L or?
What?
Is that L or?
Two.
Okay.
By chalk, just skip.
It was like some weird.
What's going on with this one?
Check out the battery, put it back in.
It's like multiplying.
It's multiplying by 3. So times 3, times 3, times 3, times 3. There's a word I've used.
Powers. Oh.
Geometric. So geometric stuff involves
Okay.
powers. 3 to a power for sure.
It's all right. I thought I just blinked.
That was weird.
So let's write down powers of 3. What's our powers of 3?
6.
369.
3, 9,
27,
27,
81.
81.
369. 14.
That's like 2%.
I don't know. Just instead of 3.
18, 20,
273. 4. 243. That's what I meant.
Can anybody see how the most effective way is? These get us in the neighborhood of those numbers.
Oh, you have to do start at 2?
The most effective way to like pair these off. Like, who does 162 best connect to out of these?
That one, 81.
81. 54 best connects to 27.
9.
9.
3.
3.
1.
And a 1. Because this is 3 to the 1 makes 3.
What did I say?
3 to the
0.
0 makes
1.
1.
So it's
So this is like involving 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, 3 to the 4. So my K's are running from 0 to 4. But it's not just these to make that little jump. It's times 2. Tomorrow, again, the geometric ones, formulas are coming. You don't have to create, you can just memorize, but for today, you just have to do your best to muddle through. Here's where we are on homework. The homework's going to go easier, harder in 4 sections. We're on 558 if you want to peek. 558, the first 8 give you the general term. And all you have to do to make answers is plug it in. So 1 to 8, they give you the general term. They want the first 4, the 10th, and the 15th. So it's a lot like this. You're just going to have a series of numbers to plug in. Then it's going to get harder and they're going to get creative. From 9 to 16, they're going to give you the pattern and you have to come up with the equation. Some of them are arithmetic, some of them are geometric, some of them are pure creativity. If you have to skip, skip. Then life gets easier again. From 17 to 22, they're back to giving you sigma notation with giving you the formula. And again, all you have to do is you just take the numbers and plug them in. But then it'll get creative and harder from 23 to 28 because they're going to give you the formula and they're going to ask you to like, or they'll give you the list of numbers and ask you to come up with a formula. 558, we're going with 1 to 28, Tomorrow, like I said, is all arithmetic, that'll be easier. The next day is all geometric, that'll be easier. The fourth day will be the easiest of the 4 days. So basically, survive today, you should be good.